Example 8.4. The work function of potassium is 2.30 electron volt. Ultraviolet light of wavelength 3000 angstrom and intensity 2 watt per meter square is incident on the potassium surface. Determine the maximum kinetic energy of the photoelectrons. If 40% of incident photons produce photoelectrons, how many electrons are emitted per second if the area of the potassium surface is 2 centimeter square? Now the work function of potassium is given as, that is 50 is given as 2.30 electron volt, and the wavelength is given as 3000 angstrom. Intensity is given as 2 watt per meter square. Okay. Now the first question is, determine the maximum kinetic energy of the photoelectrons. So for that we have to find out the energy of the incident photon. So energy of incident photon is given by the formula E is equal to h nu, which is equal to hc by lambda. Okay. So now we can write h value is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 speed of light divided by 3000 angstrom. That can be written as 3 into 10 raised to minus 7. So here the 3 and this 3 will get cancelled. So you will be getting it as what? 6.626 into 10 raised to minus 19 joules. Okay. Now this can be divided by 1.6 into 10 raised to minus 19 in order to convert it into electron volt. So if you divide 6.626 by 1.16, you will be getting it as 4.14 electron volt. Now from this energy we can go for calculating the maximum kinetic energy of photons. For that the formula used is K maximum is equal to h nu minus 50. So what is h nu? H nu is the energy, that is 4.14. 50 value is given in the problem as what? 2.30 for the potassium. So you will be getting it as 1.84 electron volt. So that's the maximum kinetic energy of the photoelectrons. Now second part of the question. If 40% of incident photons produce photoelectrons, how many electrons are emitted per second if the area of the potassium surface is 2 centimeters square? Okay. Number of photons reaching the surface per second. Okay. So that is given by the formula N is equal to intensity by energy into area. Okay. So here intensity, the intensity is 2 watt per meter square. So 2 by energy in joules is 6.626 into 10 raised to minus 19. We have calculated. Into area is given as 2 meter square, 2 centimeter square. So 2 into 10 raised to minus 4. Okay. 2 into 10 raised to minus 4. So what will you get it here? 4 by 6.626 into 10 raised to 15 will get. So this can be divided and you will be getting the answer as 6.04 into 10 raised to 14 photons per second. Okay. Now here 40% of the incident photons produce photoelectrons. Okay. So the rate of emission of photoelectrons, how much photoelectrons are produced per second or emitted per second. So the rate of emission of photoelectrons, that is 40%. 40% is 0.40 into number of electrons, number of photons. So that is 0.40 into 6.04 into 10 raised to 14. So you will be getting it as 2.416 into 10 raised to 14 photoelectrons per seconds. Okay. So this much is incident and this much is emitted.